Okay, welcome everyone. So we're going to solve Sudoku using recursion and backtracking. So firstly, let's create a static function which is going to solve the Sudoku. And our approach is going to be like this. We are going to go row by row, and whenever we encounter 0, we are going to try to put the number between 1 to 9. So firstly, our program is going to test if 1 is possible here. If not, it is going to place 2. If 2 is also not possible, it is going to place 3, and so on. So whenever it encounter some issue, it is going to remove that number and try to place another number. For example, if for example 2 is correct number here, it is just in case 2 is not the correct number here, since 2 already exists in this row. So we are going to check for 3. 3 is also not a correct number, since 3 already exists here. And next, if we check for 4, 4 is also not a correct number. Next, if we check for 5, 5 is also not a correct number. 5 exists here as well as here. And after that, if we check for 6, 6 is also not a correct number. 7 is also not a correct number. Next, if we check for 8, so 8 has not occurred in the row or in the column. So 8 can be placed here, and in this particular 3 element range, 250, 074 and 30. So 8 is also unique here in this case. So it can check the other zeros using 8. So next it would check for this number if 1 can be placed here or 2 can be placed. So 1 can be placed here, and in the future if it encounter that it cannot place an element, so it is going to backtrack and make a 0 here and try to put another element, suppose 2 or some other element. So until it get all the elements right, it is trying to solve the Sudoku. So this is going to be our approach. We are going to define this function, so Sudoku, and it is going to accept the board as a parameter, and there is going to be row and there is going to be column. Since it is a 9 cross 9 board, so row and columns are having same length. Firstly, we are going to need to define a stopping condition for our recursion, and also our main logic, that how we are going to determine if it is solvable or not. So firstly, if board row and col double equals to 0, then we need to check which number we can place. Else, we are just going to decrement the column number. So solve Sudoku board row comma col -1. So we are going to just keep scrolling to the left. If we encounter like 3, we are just going to scroll to the left. When we encounter 6, we are going to scroll to the left until we reach end. We are going to go back to the previous row and initialize the column as the board dot length -1. So column would be 4 and 7. So until it reaches 0, we are going to keep reducing our row and columns. So this is the else case when we encounter normal numbers. Suppose if call is less than 0, then we need to make call equals to board dot length -1 and row minus. So these are the things we need to do. And next, if a row is less than 0, then we need to stop. So that is one thing. Apart from that, we need to write our logic here for check if Sudoku is solved. So these are the few things that we're going to do. And here we are going to check. We are going to check for the eligibility here. So here we are going to write. So we are going to create this function which is going to check if the digit is eligible, and if the digit is eligible, it is going to place that character in that particular row and column. So it is going to place I, and is it going? It is going to go to the next solve Sudoku. And when, so for some reason it is not able to solve, it is going to put back 0. This is the backtracking condition. So when it returns from the recursion, and then it is going to put back 0. Okay, so now we just need to define our function. So we are going to create firstly we are going to check for horizontal and vertical eligibility. So if board row and I double equals to, we are going to call this variable as value. This is the value that we are trying to put. So if already exists, then it means it is not eligible. Board I. So initially we are going to assume result is true. So we encountered this case. Now we are going to call result is false and we are going to break from it. So this is next we are need to going to need to check for the particular 9 elements. Since Sudoku also need to satisfy this condition that 250, 074 and 300. This these values should also be unique and between 1 to 9. So there are like 9 rows. So our index starts with 0 and next it is 1, next is 2 and the last one this index is 8. So we need to get the row number and call number. Suppose we are considering 7. This 7 is it is at row equals to 7 and call equals to 7. So now we need to find out the this index of this particular 3 comma 3 matrix. So what we can do, we can divide 7 by 3 which is equals to 2 in the integer form, and then so our answer should be 6 comma 6 6. So 6 comma 6 should be our answer, and to get this answer we need to multiply whatever result we get by 3. So let's check it for suppose this 3 element. This is in the fourth row. 4 divided by 3 is equals to 1. Multiply by 3 is equals to 3. So its starting index of 3 cross 3 matrix is 3. So I think this condition looks okay. So what we are going to do, we are going to divide by 3 and then multiply by 3 to get the initial values. So here int s1 is equals to row divided by 3, int s2 is equals to for int I is equals to s1, I less than s1 plus 3. So here we are going to write the condition. If this, if any of the value already exists, then we're going to declare result equals to false and break. There is one more thing we can do. We can already return from here. We can avoid checking if not of result. So this can work as our eligibility condition. So we have written our eligibility condition. Now we just need to print the board. Here we can write one more condition to check if the Sudoku is really solved. But for now we can avoid. We can just print the whatever it is showing here. Print I equals to 0, okay, less than. So we are going to print. Also we can do one more thing. We can define static boolean solution found. So initially we can call that solution found equals to false, and here if solution is really found, solution found is equals to true, and we can stop further calculations of recursion by putting it inside if solution not found. Then we need to do all this. So this we can do to avoid further recursion calls. Now we can solution found. So we can create one function, check if solution. So we can go to this function. So what we're going to do for int I is equals to 0, what we can do, we can arrays dot to string. If this contains 0, then it means it failed. Control X. As it is true. Now we can try to run and check if we get any errors or some other issue. So we encountered some issue. Okay, last but not the least, we need to call our function. And so we are done with the Sudoku.